The Browning M 1919 lay in the mud of a Belgian forest, its water jacket punctured, the American crew dead around it. Obergefreiter Klaus Richter approached cautiously, his Mauser raised, expecting a trap. What he found instead would haunt him for the rest of the war, not because of the carnage, but because of what this weapon represented. A machine gun that could fire 450 rounds per minute, sustained, without melting its barrel, without jamming, without the constant stoppages that plagued the MG-34 his squad carried. He didn't know it yet, but in 48 hours, this captured American weapon would force him to write words in his diary that contradicted everything the Wehrmacht had taught him about American industrial inferiority. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. December 15th, 1944. The Ardennes Forest. The snow fell in thick curtains, muffling sound, turning the forest into a maze of white shadows. Kampfgruppe Richter, a reinforced company of the 2nd SS Panzer Division, had just overrun an American position near Malmedy. Among the captured equipment were 3 Browning M 1919 machine guns, complete with ammunition, spare barrels, and technical manuals written in English that none of the German soldiers could fully read. Richter, a mechanical engineering student from Stuttgart before the war, had been assigned to evaluate captured enemy weapons. It was a job he'd performed dozens of times since France in 1940. British Brens, Soviet Maxims, French Hotchkiss guns, he'd tested them all, documented their weaknesses, confirmed German superiority. This time would be different. The Browning was heavy, 31 pounds without the tripod, 41 with the water jacket filled. Richter's first impression was negative. The MG-34 weighed only 26 pounds. German engineering emphasized mobility, the ability for a single soldier to carry and operate the weapon. This American gun required a crew, required water, required a substantial tripod. It seemed outdated, a relic of the First World War when compared to the sleek, modern German weapons. Hauptsturmführer Werner Schultz, the company commander, shared this assessment. "Look at this thing," he said, running his gloved hand along the water jacket. "The Americans are still using water-cooled guns while we've moved to air-cooled barrels. Their engineering is a decade behind ours." But Schultz wanted a demonstration anyway. Intelligence reports suggested the Americans were using these weapons in greater numbers. Understanding enemy capabilities, even inferior ones, was standard procedure. They set up the Browning in a clearing, placing it on its tripod, filling the water jacket from canteens, loading a 250-round fabric belt. Richter had brought a stopwatch, a notebook, and a thermometer tools of systematic evaluation. The test would be simple. Fire sustained bursts, measure rate of fire, document any malfunctions, compare performance to the MG-34. Gefreiter Paul Hoffmann, who had operated an MG-34 since Poland, volunteered as the gunner. He settled behind the weapon, gripping the spade handles, his thumbs finding the butterfly trigger. "On your command, Herr Obergefreiter," he said. Richter clicked the stopwatch. "Fire." The sound was different from German machine guns. Not the sharp, rapid bark of the MG-34's faster cyclic rate of 900 rounds per minute, but a deeper, more deliberate hammering. 450 rounds per minute, Richter calculated mentally, watching the seconds tick by. Slower than German guns, but something about the rhythm felt relentless, mechanical, inexorable. Hoffmann fired in 6-second bursts, standard doctrine, pausing between bursts to observe, adjust. After 5 bursts, Richter called for sustained fire. "Keep firing, 10-second bursts, 15-second intervals. I want to see how long before it malfunctions." 10 bursts, 20, 30. Hoffmann's initial skepticism was transforming into something else, respect tinged with unease. The Browning functioned flawlessly. No jams, no stoppages, no misfeeds. The water jacket grew warm, then hot, but the gun continued firing. At 50 bursts, Richter checked his calculations. They'd fired over 2,000 rounds. The MG-34, with its air-cooled barrel, would have required a barrel change by now. Overheating caused loss of accuracy, potential cook-offs, even catastrophic failure if pushed too hard. The Browning simply kept firing. Continuous fire, Richter ordered, his scientific curiosity overcoming tactical caution. Sustain for 60 seconds. This violated every principle of German machine gun doctrine. Continuous fire caused overheating, wasted ammunition, invited enemy counterfire. But Richter needed to find this weapon's breaking point. Hoffmann pressed the trigger and held it. The Browning roared, a sustained thunder that echoed through the frozen forest. 450 rounds per minute meant 450 opportunities for something to go wrong. Worn springs, damaged feed mechanisms, warped components, the stress of continuous fire exposed every weakness in a weapon's design. German machine guns were magnificent weapons, but they had limits. Everything had limits. 60 seconds, 450 rounds. The barrel glowed faintly, even in daylight. Steam rose from the water jacket. The snow around the gun had melted from radiated heat, but the Browning was still firing. Richter felt something shift in his understanding. This wasn't just a functional weapon, this was a weapon designed for sustained fire in a way German guns were not. "Cease fire," he finally ordered. Hoffmann released the trigger, and silence crashed back over the clearing. The German soldiers stood motionless, processing what they'd witnessed. Schultz approached the weapon, touching the water jacket cautiously. "It's hot," he said unnecessarily, "but not critically so. The water cooling is more efficient than I expected." Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. Richter examined the gun mechanically, professionally, fighting against the implications of what he was seeing. The bolt moved smoothly. The feed mechanism showed no signs of stress. The barrel, viewed through the chamber, retained clean rifling without heat damage. He checked his ammunition count. 2,800 rounds fired. 0 malfunctions. 0 stoppages. 0 failures of any kind. In his notebook, he wrote carefully in pencil, his handwriting precise despite the cold. Browning M, 1919, demonstrates exceptional reliability under sustained fire conditions. Rate of fire 450 rounds per minute confirmed. No mechanical failures observed after 2,800 rounds continuous and burst fire. Water cooling system highly effective. Weapon continues to function at full capacity. Then, after a long pause, he added a sentence that felt like betrayal. Performance exceeds MG-34 under sustained fire conditions. The words sat on the page like an accusation. Richter stared at them, wanting to cross them out, to qualify them, to explain that German weapons were superior in other ways: mobility, rate of fire, tactical flexibility. But the sentence was true. In this one critical measure, the American weapon was better. He closed the notebook and looked at Schultz, who was watching him with an expression Richter couldn't quite read. "Your assessment, Obergefreiter?" Schultz asked quietly. "The weapon is highly effective for sustained defensive fire, Herr Hauptsturmführer," Richter replied carefully. "The water cooling system allows prolonged firing without barrel changes. Rate of fire is lower than our weapons, but reliability appears exceptional." Schultz nodded slowly. "And if we faced a defensive position equipped with a dozen of these guns, each one capable of firing continuously without overheating?" Richter didn't answer immediately. The tactical implications were cascading through his mind. A dozen Brownings, properly positioned, could lay down 5,400 rounds per minute, continuously, without barrel changes, without mechanical failures, without the tactical pauses that German doctrine required to prevent overheating. It would be a wall of lead, impenetrable, unrelenting, sustained for as long as ammunition lasted. "It would be difficult to assault, sir," Richter said finally, the understatement hanging in the frozen air. Difficult. The word was inadequate. It would be suicide. But officers didn't use that word, even when it was true. The testing continued over, in the next 3 days. Kampfgruppe Richter had captured enough American ammunition to conduct extensive trials. They tested the other two Brownings, finding identical performance. They tested in snow, in rain, in the bitter cold that made German weapons sluggish and temperamental. The Brownings functioned perfectly. They tested accuracy, firing at targets ranging from 100 to 1,000 meters. The sustained fire capability meant the guns could be used for suppressive fire at distances. German machine guns could only engage in short bursts. They tested the interchangeability of parts, finding that components from one gun fit perfectly in another. American mass production, they realized, meant standardization at a level German manufacturing had never achieved. On the third day, they captured an American technical manual that Lieutenant Friedrich Weber, who had studied at Oxford before the war, could partially translate. What he read troubled him deeply. According to this manual, Weber said, translating haltingly from English, the Browning M1919 is designed for sustained fire of 250 rounds per minute, indefinitely without barrel change. The 450 round per minute rate we tested is specified as normal combat rate. The weapon can theoretically fire up to 600 rounds per minute in emergencies, though this is not recommended for extended periods. Schultz frowned. What do they mean by indefinitely? Weber checked the manual again. It says here that with proper water supply and ammunition, the weapon can maintain fire for hours without mechanical failure. There are documented cases from the First World War of single guns firing 40,000 rounds in a day. 40,000 rounds. The number seemed impossible. The MG-34, superb as it was, required multiple barrel changes, constant maintenance, careful monitoring to fire even 10,000 rounds in a day. And here was an American weapon, designed in 1919, that could exceed that by 4 times. Richter found himself doing calculations in his notebook, working through the mathematics of sustained fire. A single Browning, with adequate ammunition and water, could control a sector of fire absolutely. The 450 round per minute rate meant a bullet every 1/8 of a second. The beaten zone, the area covered by fire, would be continuously swept by projectiles with almost no gaps for an attacker to exploit. German assault doctrine relied on identifying pauses in enemy fire, moments when machine guns stopped to reload or change overheated barrels. These pauses allowed infantry to advance by rushes, closing with the enemy position. Against weapons that didn't pause, that didn't overheat, that simply kept firing continuously, the doctrine collapsed. Advancement became impossible. Infantry were forced to ground, pinned, helpless under sustained fire. We need to report this to division, Schultz said finally, and Richter heard reluctance in his voice. Reporting captured enemy equipment was standard procedure, but reporting that enemy equipment was superior to German weapons felt like defeat, an admission that contradicted years of propaganda about American industrial inferiority. Yet the evidence was undeniable. The Brownings sat in the clearing, cold and factual, ready to fire another 40,000 rounds if needed. Richter wrote his official report that evening, hunched over a map table in a commandeered Belgian farmhouse, an oil lamp casting shadows across his careful handwriting. He structured the report in the dry, technical language of military evaluation, describing specifications, performance metrics, comparative analysis. But even stripped of emotion, the facts told a disturbing story. The Americans had designed and mass-produced a weapon system that exceeded German capabilities in sustained defensive fire. More troubling, they had done so 25 years earlier, in 1919, and had apparently seen no need to replace it because nothing better was required. The report went up the chain of command, through battalion to regiment to division. It joined hundreds of other reports from the Ardennes offensive, tactical assessments of American weapons, American tactics, American capabilities. Most were filed and forgotten, buried in the chaos of Germany's deteriorating military situation. But some officers read Richter's report with recognition and growing dread. They had encountered the Brownings themselves. They had watched their infantry cut down by sustained fire that never seemed to end. They had lost entire companies to defensive positions that could maintain fire indefinitely. and they were beginning to understand a terrible truth that propaganda had concealed. American industrial might wasn't just producing more weapons, it was producing better weapons. Weapons designed with a philosophy fundamentally different from German engineering. German machine guns were designed for mobile warfare, for advancing, for offense. They emphasized high rates of fire, portability, the ability for a single soldier to operate effectively. They were weapons for an army on the attack, an army that believed in victory through movement and aggression. The Browning was designed for a different kind of war. It was a defensive weapon, heavy, requiring a crew, requiring support infrastructure. But in defense, it was nearly perfect. It embodied a philosophy that valued sustained performance over burst capability, reliability over rate of fire, endurance over mobility. It was a weapon for an army that could afford to be patient, that had time and resources on its side, that could afford to let the enemy exhaust themselves against impregnable positions. Richter would test captured Brownings 4 more times during the winter of 1944 and 1945. Each test confirmed his initial findings. The weapons were boringly, devastatingly reliable. They fired when triggered. They stopped when released. They required minimal maintenance. They functioned in conditions that made German weapons falter: extreme cold, mud, inadequate lubrication. They represented a manufacturing philosophy that prioritized function over elegance, reliability over sophistication. They were not beautiful weapons. German engineers had always valued aesthetic design, the marriage of form and function that made German weapons distinctive. The MG-34 was a work of mechanical art, precision machined, perfectly balanced, a joy to operate. The Browning was utilitarian, heavy, graceless, but it worked. In the end, that was all that mattered. By January 1945, Richter's company had retreated back into Germany, driven from Belgium by American counterattacks. They still carried 1 captured Browning, supplementing their dwindling supply of MG-34s. German soldiers, initially contemptuous of the heavy American weapon, had learned to appreciate its virtues. When ammunition was available, when water could be found, the Browning provided covering fire that allowed retreats to succeed, that held positions long enough for units to disengage and fall back. It became a trusted weapon, valued not for ideological reasons but for practical effectiveness. The gun that had been a curiosity in December was a lifeline by March. Richter's diary entries from this period showed his evolving understanding. In December, he wrote about technical specifications, about rates of fire and mechanical reliability. By February, he was writing about implications, about what the Browning revealed about American industrial capacity and military philosophy. "They build weapons that work," he wrote on February 23, 1945. "Not weapons that impress at parades or look elegant in photographs, but weapons that function under the worst conditions, that soldier can depend on absolutely." This should frighten us more than their numbers, because it suggests they understand warfare at a level we do not. It was a profound admission from a German soldier, trained to believe in German technical superiority, in the myth of Aryan engineering genius. But the evidence was undeniable. The Browning worked. It had worked in the First World War. It worked in the Second World War. It would work, Richter suspected, in any war, because it was designed with an understanding of what sustained combat actually required. Not elegance, not sophistication, not even mobility, just relentless, unbreakable reliability. The Americans had understood something fundamental. In war, the weapon that fires when you need it is worth more than the weapon that fires faster when it works. The Browning fired when you needed it, every time, without fail, and that made it, despite its age, despite its weight, despite its apparent simplicity, one of the most effective weapons of the war. The winter of 1945 brought Obergefreiter Klaus Richter face to face with a truth more devastating than any battlefield defeat. As his unit retreated deeper into Germany, they encountered other Wehrmacht units, other captured American weapons, and other soldiers who had reached the same disturbing conclusion. The Browning M1919 was not an anomaly. It was a symptom of something far larger, a fundamental difference in how America approached industrial warfare that Germany had catastrophically misunderstood. Lieutenant Friedrich Weber had managed to acquire more American technical documents during the retreat. Some were captured from overrun supply depots, others taken from destroyed American vehicles. A few even traded from other German units who recognized their intelligence value. Weber spent his evenings translating these documents by candlelight, and what he discovered kept him awake long after the candles burned down. The Browning M 1919, he learned, was designed by John Moses Browning and adopted by the United States military in 1917. It had served in the First World War, firing millions of rounds in the trenches of France. After that war, while Germany was forbidden from developing military weapons under the Versailles Treaty, America had continued manufacturing Brownings, not in small numbers for elite units, but in massive quantities for general issue. Weber found production records in a captured logistics manual. By 1941, before America even entered the war, over 200,000 Browning M 1919 machine guns had been manufactured. The number seemed impossible until Weber cross-referenced it with other documents. America had supplied Brownings to Britain under Lend-Lease, to China, to Free French forces, to any ally who needed machine guns, and still had enough for their own military with reserves stored in depots across the continental United States. They built these guns for 25 years, Weber told Richter one evening in late January, surrounded by translated documents. 25 years of continuous production. They refined the manufacturing process until they could produce each gun for less cost than our MG-34, despite the Browning being heavier and more complex. The technical manual mentions that parts are standardized across all production runs, meaning a replacement bolt manufactured in 1918 fits perfectly in a gun made in 1943. Richter understood the implications immediately. German weapons manufacturing, superb as it was, suffered from constant modifications. The MG-34 had been upgraded, improved, refined multiple times since its introduction in 1934. These improvements made the weapon better, but they also meant parts weren't always interchangeable between production runs. A bolt from an early model might not fit a later version. Armories had to stock multiple variants of the same part. Supply became complicated, maintenance more difficult. The Americans had solved this problem through what Weber called frozen design. They had perfected the Browning by 1920 and then simply kept building it identically for 25 years. No improvements, no refinements, no elegant engineering modifications. Just the same proven design, manufactured to exacting standards, over and over, building an arsenal of utterly reliable weapons that would function anywhere, anytime, under any conditions. It was the opposite of German engineering philosophy, which valued continuous improvement, elegant solutions, technical sophistication. But it worked. Perhaps, Richter was beginning to realize, it worked better. Hauptsturmführer Werner Schultz had drawn his own conclusions from the Browning tests. In early February, he gathered his remaining officers for a tactical discussion that became something more a moment of brutal honesty that would have been impossible earlier in the war. "Gentlemen," Schultz began, "we need to discuss what we've learned from American weapons, particularly the Browning machine gun, not for intelligence purposes, though that remains valuable, but because our tactics must adapt to battlefield realities." The officers sat in the ruins of a German farmhouse, men whose units had been ground down from companies to platoons, from battalions to scattered remnants. They had all encountered American weapons. They had all lost men to sustained machine gun fire that never seemed to pause, never seemed to end. "The Americans fight differently than we do," Schultz continued. "We emphasize maneuver, aggression, mobile warfare. We attack, they defend. We advance rapidly with light weapons. They establish positions with heavy weapons and weight. We assumed this was weakness, that defensive mentality indicated lack of offensive spirit. But what if it's not weakness? What if it's strategy?" Oberleutnant Martin Kruger, who had commanded the company's heavy weapons platoon before it was destroyed, spoke carefully. "The Browning is designed for defense, Herr Hauptsturmführer. Heavy, difficult to move, but devastating when positioned. They build positions around their machine guns rather than carrying machine guns into positions. It's a different tactical philosophy. And if that philosophy is supported by unlimited industrial capacity, Scholz asked, if they can place a dozen Brownings in every defensive position, if they can supply each gun with 10,000 rounds of ammunition, what then? The silence that followed was answer enough. German assault tactics relied on identifying weak points in enemy defenses, exploiting gaps in covering fire, advancing during the brief moments when machine guns reloaded or changed overheated barrels. Against positions where machine guns never overheated, never needed barrel changes, never stopped firing, the tactics collapsed. Infantry couldn't advance through continuous fire, couldn't rush during pauses that never came, couldn't exploit weaknesses that didn't exist. Richter found himself thinking about the mathematics of sustained fire again. A single Browning, firing 450 rounds per minute, created approximately 125 opportunities per minute for a fatal hit within its beaten zone. 12 Brownings, a reasonable number for a company-sized defensive position, created 1,500 opportunities per minute, 90,000 per hour. Against such fire, advancing across open ground wasn't brave, it was mathematically impossible. The German army had been designed for attack, for breakthrough, for rapid exploitation of tactical success. They had conquered Poland in weeks, France in months, driven deep into the Soviet Union in a single summer. Mobile warfare was their doctrine, their identity, their understanding of how wars were won. But they were no longer attacking, they were defending, and they were defending with weapons, designed for attack, against an enemy whose weapons were designed for exactly this kind of warfare. The Browning revelation extended beyond tactics to logistics. Weber's translated documents revealed that each American infantry regiment was authorized 24 Browning M1919 machine guns. Each division had 72. The Americans had standardized their table of organization and equipment across all divisions, meaning every American division that landed in Europe had identical firepower, identical capabilities, identical weapons loads. German divisions, by contrast, varied wildly in equipment depending on their priority, their formation date, their theater of operations. Elite divisions received the newest weapons. Regular infantry divisions made do with older equipment. Second-line divisions received captured weapons, obsolete models, whatever was available. This variation made sense in German military culture, which valued elite units and accepted that not all soldiers could be equally equipped. But it created nightmare logistics. Supply officers had to stock parts for a dozen different machine gun models. Armourers had to be trained on multiple weapon systems. Tactical planning had to account for different capabilities across units. The Americans had rejected this complexity. Every division was identically equipped. Every machine gun was a Browning. Every part was interchangeable. Every soldier received identical training. It was the same philosophy that had produced the Browning itself: standardization over sophistication, reliability over elegance, industrial efficiency over craft perfection. And it worked. American logistics functioned smoothly, even under the chaos of combat, because there were no variations to track, no special cases to manage, no complexity to navigate. A supply truck carrying Browning parts could service any unit because every unit had identical weapons. Simple, effective, devastating in its implications. Richter spent a February evening examining the Browning his unit still carried, looking at it with new understanding. The weapon's design revealed its philosophy in every component. The water jacket wasn't elegant, but it solved the overheating problem absolutely. The belt-fed mechanism was heavy, but it allowed continuous fire without reloading pauses. The tripod mount was cumbersome, but it provided stability for sustained, accurate fire. Every design choice prioritized function over form, effectiveness over appearance, reliability over sophistication. Nothing was wasted on aesthetics. Nothing was included that didn't directly contribute to the weapon's combat effectiveness. It was, Richter realized, the most honest weapon he had ever encountered. It made no pretense of being more than it was: a machine for producing sustained, accurate fire. But it was the best possible machine for that purpose, refined over 25 years of production, proven in 2 world wars, trusted absolutely by soldiers who depended on it. The MG-34, by contrast, was a more sophisticated weapon in many ways. Higher rate of fire, lighter weight, easier to carry, more versatile in different combat roles. German soldiers loved the MG-34, loved its quick-change barrel, its drum and belt feed options, its use both as a light machine gun on bipod or heavy machine gun on tripod. It was, genuinely, a more advanced weapon than the Browning in many respects. But it couldn't match the Browning's sustained fire capability. It couldn't fire continuously without barrel changes. It couldn't maintain 450 rounds per minute indefinitely. And in defensive warfare, which was increasingly all the German army was capable of, that limitation was fatal. By March 1945, Richter's unit had been pushed back across the Rhine. They were fighting in Germany now, defending their homeland against enemies attacking from east and west. The strategic situation was hopeless, everyone knew it, though no one said it openly. But tactical fighting continued, small unit actions, delaying actions, desperate attempts to slow the Allied advance. In these actions, the captured Browning became invaluable. Positioned to cover a bridge, a crossroads, a narrow valley, the weapon could hold up American advances for hours. Its sustained fire forced American infantry to ground, forced them to call for artillery, for air support, for tanks. It bought time, which was all the German army had left to trade. Gefreiter Paul Hoffmann, who had fired the first test bursts back in December, had become the Browning's dedicated gunner. He had learned its characteristics intimately, the way the spade grips vibrated during sustained fire, the steam that rose from the water jacket after prolonged firing, the specific sound that indicated the belt was nearly exhausted and needed changing. He had developed a relationship with the weapon that went beyond technical proficiency into something almost spiritual. The Browning, he told Richter once, was the only thing in this war that did exactly what it was supposed to do, every single time, without fail. In a world of chaos, mechanical failure, and broken promises, that reliability mattered more than anything. On March 23, 1945, Hoffmann used the Browning to cover a company withdrawal across a damaged bridge near Remagen. American infantry were advancing cautiously, using buildings for cover, working their way forward in rushes coordinated with their own machine gun fire. Standard tactics, well executed, supported by superior numbers and firepower. Hoffmann waited until they were committed, until they were in the open, crossing a plaza, and then opened fire, 450 rounds per minute. Sustained. Without pausing, the Americans went to ground immediately, seeking any cover, unable to advance or retreat through the continuous fire. Hoffmann traversed the gun slowly, methodically, keeping the entire plaza under fire, forcing the Americans to remain pinned. He fired for 7 minutes continuously, over 3,000 rounds, the barrel glowing, steam pouring from the water jacket, but the gun never jammed, never misfired, never failed. Behind him, the German company completed their withdrawal, crossed the bridge, prepared demolition charges. When Hoffmann finally ceased fire and fell back himself, the Browning had bought enough time for the mission to succeed. The bridge was blown. The Americans were delayed for another day. It was a tiny tactical victory in a war that was strategically lost, but it mattered to the men who survived because of it. That night, cleaning the Browning in a cellar while American artillery thundered overhead, Hoffmann spoke to Richter with unusual emotion. "This gun saved our lives today," he said quietly. "An American weapon saved German lives because it works better than our own weapons. What does that say about everything we were told? About German superiority? About American inferiority? About any of it?" Richter had no answer. The question had been growing in his mind for months, fed by every test, every combat action, every translated document. What did it say about German ideology when American weapons proved more reliable? What did it say about Nazi propaganda regarding American industrial weakness when a single American weapon design, 25 years old, outperformed Germany's newest machine guns in sustained fire? What did it say about the entire basis of the war when the racially inferior, culturally decadent Americans produced better tools than the master race? These questions were dangerous, potentially treasonous. Asking them openly could mean arrest, court-martial, execution. But in March 1945, with Germany collapsing on all fronts, with the end visibly approaching, such questions couldn't be suppressed any longer. They forced their way into consciousness, demanded examination, refused to be ignored. The Browning sat in the corner of the cellar, water jacket still warm, barrel still gleaming with oil. It was just a machine, just metal and mechanical parts, designed by an American Mormon from Utah, manufactured by workers in factories across the United States, fired by German soldiers in the ruins of Germany. But it represented something larger than itself. It represented industrial philosophy, military strategy, national character. It represented a truth that German propaganda had concealed, and German pride had refused to acknowledge that America's approach to warfare, derided as unimaginative and materialistic, was devastatingly effective precisely because it prioritized function over ideology, reliability over elegance, practical effectiveness over theoretical superiority. Lieutenant Weber had found one final document in a captured American supply depot, a technical bulletin from 1943 discussing Browning ammunition expenditure rates. According to the document, American factories were producing 30 million rounds of .30 caliber ammunition per month, specifically for the Browning M 1919. 30 million rounds per month, just for one weapon system. The number was so large, Weber initially thought he had mistranslated, but checking multiple sources confirmed it. 30 million rounds monthly, 360 million annually, meant every Browning in American service could theoretically fire over 1,000 rounds per month in sustained combat and never run short of ammunition. "They've solved the entire problem," Weber told Richter, explaining his calculations. "Weapon design, manufacturing, standardization, logistics, ammunition production. They've created an integrated system where every component supports every other component. The gun is reliable because it's designed for reliability. It's manufactured consistently because they don't try to improve it constantly. It's supplied adequately because they produce ammunition in quantities we can't imagine, and it's employed effectively because their tactics are built around its strengths." It was, Richter realized, exactly what German military planners had always claimed to do, integrate all aspects of warfare into a coherent system. But the Americans had actually done it, while Germany had produced brilliant individual weapons that were nevertheless hampered by supply problems, maintenance difficulties, ammunition shortages, and tactical doctrines that didn't fully leverage their capabilities. The final lesson came in early April. Richter's unit, reduced now to barely platoon strength, was defending a village east of the Rhine against advancing American forces. They had positioned the Browning to cover the main approach, with Hoffman behind the gun as always. When the Americans attacked, they came with overwhelming force, infantry, armor, artillery, air support. The German position was untenable from the start. But Hoffman fired anyway, sustained bursts into the advancing infantry, buying time for others to fall back. He fired until the ammunition was exhausted, until American tanks began targeting his position directly, until Schultz personally ordered him to abandon the weapon and retreat. Even then, Hoffman hesitated, reluctant to leave behind the gun that had never failed him, the American weapon that had proven more reliable than anything German industry had provided. They left the Browning in the rubble of the village, still functional, still capable of firing if ammunition were available. An American weapon, captured by Germans in Belgium, carried across Germany, used in a dozen defensive actions, finally abandoned in the ruins of a German village as the Wehrmacht collapsed. Richter thought about writing its story in his diary, but found he had no words adequate to the task. How do you summarize the psychological impact of discovering your enemy's weapons are better than your own? How do you process the realization that everything you were told about enemy inferiority was propaganda contradicted by mechanical reality? How do you maintain faith in ultimate victory when a 25-year-old enemy weapon design outperforms your newest military hardware? The Browning had taught Richter a lesson more profound than any he had learned in engineering school or Wehrmacht training. Excellence wasn't about sophistication or elegance or theoretical superiority. Excellence was about working reliably when it mattered, about doing the job you were designed for without fail, about being the tool that soldiers could depend on absolutely in the worst moments of combat. The Browning was excellent. It had been excellent in 1918. It was still excellent in 1945. It would probably be excellent for decades to come, because true excellence was timeless, not dependent on fashion or ideology or national pride, but on fundamental effectiveness measured by the harshest possible test: combat. As Richter retreated with the remnants of his unit through a Germany collapsing on all fronts, he carried that lesson in his mind like a weight. The Wehrmacht was defeated not just by numbers or strategy or Allied cooperation, but by an industrial philosophy that Germany had failed to understand and had paid for that failure with everything. The Americans had built weapons that worked, manufactured them in quantities that ensured supply, and employed them with tactics that maximized their strengths. They had done this not through racial superiority or ideological fervor or military genius, but through practical industrial logic applied consistently across their entire war effort. They had built an arsenal not of wonder weapons or theoretical superiority, but of reliable tools that functioned exactly as designed every single time. And that, ultimately, was more powerful than anything Germany had produced: the simple, devastating power of things that worked when you needed them to work, without fail, without excuse, without exception. April 1945 found Klaus Richter in a prisoner of war camp near Mannheim, surrounded by thousands of other Wehrmacht soldiers who had surrendered to advancing American forces. The war was ending, everyone knew it, and most felt only relief that they had survived. But Richter carried something unusual into captivity: his notebooks, containing detailed technical evaluations of the Browning M1919, observations that would eventually make their way to American intelligence officers and reveal just how profoundly the weapon had affected German tactical thinking in the war's final months. The American officers who interviewed Richter were initially skeptical of his claims. A German engineer praising American weapons seemed like an attempt to curry favor, to make himself useful to his captors. But when they read his technical notes, measured his calculations, reviewed his systematic documentation, they realized he was offering something more valuable than flattery: genuine technical insight into how German soldiers had perceived American military hardware. Captain Robert Henderson, an ordnance officer from the Aberdeen Proving Ground in Maryland, spent 3 days interviewing Richter through an interpreter. Henderson had helped develop technical manuals for the Browning and was intimately familiar with its capabilities. But he had never considered what the weapon looked like from the other side, how it appeared to enemies who encountered it in combat. "You write here that the Browning's sustained fire capability exceeded anything in the German arsenal," Henderson said, pointing to a passage in Richter's notebook. "Did your commanders understand this? Did they change tactics because of it?" Richter considered his answer carefully. Even in defeat, discussing German tactical weaknesses felt like betrayal. But the war was over, and perhaps truth mattered, more than loyalty to a cause that had proven itself catastrophically wrong. By late 1944, yes, our commanders understood, Richter replied through the interpreter. "We modified assault tactics to account for continuous machine gun fire. We learned to avoid open approaches where Brownings could establish overlapping fields of fire. We learned that your defensive positions were nearly impossible to assault directly because your guns never stopped firing long enough for us to advance." Henderson nodded, making notes. "And before that? Early in the war?" "Before that, we dismissed American weapons as inferior," Richter admitted. "We believed our own propaganda about American industrial weakness, about weapons hastily built by unskilled workers. The first time I tested a captured Browning, I expected to find flaws, weaknesses, confirmation of German superiority. Instead, I found a weapon that worked better than anything we had for sustained defensive fire." This admission, documented in Henderson's interview notes, would later appear in American military analysis of the European theater. But more importantly, it would influence American defense policy for decades to come, reinforcing the philosophy that had produced the Browning, that reliability and sustained performance mattered more than theoretical capability or sophisticated design. Other German prisoners told similar stories. Feldwebel Hans Krieger, captured near the Ruhr, described a defensive action in February where 3 Brownings held up an entire German battalion for 6 hours. "We couldn't advance," he told his interrogators. "Every time we tried to move, the machine guns opened fire and didn't stop. We tried artillery, but you repositioned the guns during the bombardment. We tried infiltration, but your guns covered every approach. In the end, we withdrew with 30% casualties and achieved nothing." Oberleutnant Ernst Wagner, a company commander from the 7th Army, provided a tactical analysis that American officers found valuable. "The Browning changed how we approached defensive positions," Wagner explained. "Early in the war, we assumed machine guns would fire in short bursts, that there would be pauses we could exploit. Against Brownings, there were no pauses. We had to modify our entire assault doctrine, use more artillery preparation, accept higher casualties, and often bypass strong points entirely rather than assault them directly." These interviews revealed something American military planners hadn't fully appreciated, that the Browning M1919 had become a psychological weapon as much as a physical one. German soldiers feared sustained machine gun fire more than artillery, more than air attack, more than tanks. Artillery eventually stopped, air attacks passed, tanks could be avoided or ambushed. But the Brownings just kept firing, relentless, mechanical, inhuman in their consistency. That psychological impact, multiplied across thousands of defensive positions throughout the European theatre, had contributed significantly to German tactical paralysis in the war's final year. Lieutenant Friedrich Weber, Richter's colleague who had translated American technical documents, provided perhaps the most insightful analysis during his interrogation. Weber had studied at Oxford before the war and spoke fluent English, allowing him to communicate directly with American officers without an interpreter. The Browning represents a fundamentally different approach to military engineering than German weapons, Weber told a group of American ordnance officers assembled to hear his assessment. "German engineers pursue perfection. We constantly improve, refine, upgrade our weapons to achieve theoretical superiority. American engineers pursue adequacy. You design weapons that are good enough to do the job reliably, then manufacture them in quantities that ensure availability." "And which approach is superior?" one of the American officers asked. Weber smiled sadly. "You won the war, didn't you? That's the answer. German weapons were often superior in specific technical measures: rate of fire, accuracy, weight, sophistication of design. But American weapons were superior in the measures that actually matter in prolonged industrial warfare: reliability, manufacturability, standardization, availability. You could produce 10 Brownings for every MG-34 we manufactured, and each of your guns was more reliable than ours in sustained combat. Quality is meaningless if you don't have enough quantity to employ it effectively." This assessment, recorded in April 1945, would influence American military procurement for generations. The philosophy of good enough, manufactured in adequate quantity, became doctrine, shaping everything from the M16 rifle to the M113 armored personnel carrier to the F-16 fighter jet. The Browning had proven that reliability and availability could trump theoretical superiority, and American defense planners would never forget that lesson. Meanwhile, in the POW camps, ordinary German soldiers were experiencing their own revelations about American industrial capacity. They were being fed better than they had eaten in years, housed in barracks with hot water and electricity, given medical care that exceeded what German civilians were receiving. And they were seeing American logistics in action: the endless convoys of trucks, the supply depots that never seemed to run short, the casual efficiency of an army that had solved the basic problems of keeping soldiers fed, equipped, and supported. Gefreiter Paul Hoffmann, who had been the Browning's gunner through the final months of fighting, found himself assigned to work details unloading American supply trucks. What he saw astonished him: crates of machine gun ammunition stacked in quantities he had never imagined, spare barrels for Brownings wrapped and warehoused by the hundreds, replacement parts organized and available in amounts that seemed excessive until he understood American logistics philosophy. They didn't calculate minimum necessary supply, they calculated maximum possible consumption and exceeded it, ensuring that no unit ever ran short due to supply chain inefficiency or unexpected demand. "We fought the last year of the war with inadequate ammunition for our machine guns," Hoffman told Richter during one of their conversations in the camp. "We rationed belts, fired in short bursts to conserve ammunition, sometimes held fire entirely to save rounds for more critical moments. And here, the Americans have warehouses full of ammunition they'll probably never use, stockpiled just to ensure they never run short. That's the difference between our armies. We calculated what we needed and fell short. They calculated what they might need and exceeded it." This abundance, witnessed daily by hundreds of thousands of German prisoners, demolished whatever remained of Nazi propaganda about American weakness. The prisoners saw an army that could afford to waste resources, that threw away equipment that would have been precious in Germany, that fed enemies better than Germany fed its own soldiers. They saw the physical manifestation of industrial superiority so overwhelming that resistance had always been futile, victory had always been impossible, and the war had been lost from the moment America entered it. Richter spent his months in captivity writing an expanded technical analysis of the Browning, incorporating everything he had learned from testing, from combat employment, from conversations with other German soldiers, and from observing American logistics. The document, eventually running to over 100 pages, became a meditation on military philosophy as much as technical evaluation. He wrote about the mathematics of sustained fire, about the logistics of ammunition supply, about the tactical implications of reliable weapons. But he also wrote about the deeper lesson the Browning taught, that honesty in design, that accepting what was good enough and perfecting it rather than endlessly pursuing theoretical improvement, that valuing function over form could produce results that sophisticated perfectionism could never match. "The Browning is not a beautiful weapon," Richter wrote in his conclusion. "It is heavy, cumbersome, outdated in concept. It uses a cooling system that other nations abandoned decades ago. It fires slower than modern machine guns. It requires a crew and support infrastructure. By German engineering standards, it should be obsolete, replaced by more advanced designs. Yet it remains the most effective sustained fire weapon I have encountered, and it achieved that effectiveness through the simplest possible means by being designed to work reliably and then being manufactured without change for 25 years. There is genius in this simplicity, wisdom in this restraint, power in this, a refusal to pursue perfection at the cost of reliability." American ordnance officers who read Richter's analysis found it valuable not because it told them anything new about the Browning's technical specifications, but because it revealed how enemies perceived American weapons and what that perception meant for future conflicts. The report was classified and filed in Aberdeen Proving Grounds archives, where it would influence decisions about machine gun development for the next 2 decades. When American ordnance officers debated whether to replace the Browning with newer designs in the 1950s and 1960s, someone always retrieved Richter's report and pointed out that even enemies acknowledged the weapon's superiority in sustained fire. If it wasn't broken, why replace it? The Browning M1919 remained in American service long after the Second World War ended. It fought in Korea, where the sustained fire capability proved valuable in defensive positions against human wave attacks. It fought in Vietnam, where its reliability in tropical conditions and sustained fire capability made it valuable for base defense. Modified versions remained in service into the 1970s, over 50 years after the weapon's initial adoption. Some estimates suggest Brownings fired more rounds in combat than any other machine gun in history, a testament to both longevity and combat effectiveness. Richter himself was repatriated to Germany in 1946, returning to a country devastated by war, occupied by former enemies, struggling to rebuild from complete collapse. He returned to his studies, eventually earning a doctorate in mechanical engineering from the University of Stuttgart. His dissertation, completed in 1951, was titled Reliability in Military Systems Design, a comparative analysis of American and German weapon development philosophy. It incorporated his wartime experience with the Browning, though, without explicitly identifying the weapon. The dissertation argued that reliability should be valued above sophistication in military equipment design, that standardization enabled logistical efficiency, and that good enough, available in quantity, was superior to perfection available in limited numbers. The ideas were controversial in German engineering circles, where precision and continuous improvement remained cultural values. But Richter's dissertation influenced a generation of German engineers who worked on NATO weapons projects during the Cold War, helping to bridge the gap between German perfectionism and American pragmatism. In 1973, Richter attended a NATO weapons conference in Brussels, where the guest speaker was retired Colonel Robert Henderson, the American ordnance officer who had interviewed him in the POW camp 28 years earlier. After the presentation, Richter approached Henderson, introduced himself, and reminded him of their previous meeting. Henderson remembered immediately. "You wrote the analysis of the Browning," he said, shaking Richter's hand warmly. That report influenced American machine gun development for decades. We still cite it when discussing reliability versus sophistication trade-offs. The two men spent the evening discussing weapons design philosophy, comparing notes on how the Brownings' lessons had influenced their respective careers. Henderson revealed that American military planners had used Richter's analysis to argue against replacing the Browning with more sophisticated but less reliable designs. Richter described how his dissertation had helped German engineers appreciate the value of reliability over perfection. Both men had carried the Brownings' lessons through their entire careers, applying them to projects far removed from machine guns but still shaped by the fundamental insight that reliability mattered more than sophistication. "The Browning taught me something important," Richter told Henderson that evening in Brussels. "It taught me that the best solution isn't always the most elegant or the most advanced. Sometimes the best solution is the one that works every time, without fail, under the worst possible conditions. That's a lesson I've applied to every project I've worked on since the war." Henderson nodded. John Browning understood that from the beginning. He designed weapons that soldiers could depend on absolutely, and he refused to add complexity that might compromise reliability. The M1919 worked in 1917, and it still worked in 1970, because the fundamentals were right from the start. That's the mark of true engineering genius, not creating something complex, but creating something simple that works perfectly. Both men were quiet for a moment, contemplating the strange path that had led from a Belgian forest in December 1944 to a conference room in Brussels in 1973. A captured weapon had changed both their lives, had influenced their thinking, had shaped their careers. It had taught Richter that his enemies were not inferior but merely different in approach, and that their approach had proven more effective in the only test that mattered: actual warfare. It had taught Henderson that the weapons his country produced were valued even by enemies, that reliability was recognized as a virtue even by those it was used against. The Browning M1919 fired its final combat rounds in American service in the mid-1970s, ending a service life of over 50 years. Some weapons remained in storage or reserve units for years afterward, and modified versions continued serving in other nations' armies well into the 21st century. By any measure, it was one of the most successful weapon designs in military history, proven in 2 world wars, Korea, Vietnam, and countless smaller conflicts. But perhaps its greatest impact was not measured in depacked rounds fired or enemies suppressed, but in the lesson it taught about the nature of effective design. Excellence, the Browning demonstrated, was not about sophistication or complexity or theoretical superiority. Excellence was about doing one job supremely well, about working reliably under any conditions, about being the tool that soldiers could trust absolutely in the worst moments of combat. Klaus Richter never forgot that lesson. In his long career as an engineer, he applied Browning's principles to everything he designed: prioritize reliability over sophistication, perfect the fundamentals before adding features, test under harsh conditions, standardize for manufacturability. His work influenced German industrial design in the post-war era, helping to create products known worldwide for reliability and quality. He never claimed his philosophy came from an American machine gun he had tested as an enemy soldier, but those who knew his history understood the connection. The weapon that had shattered his faith in German superiority had given him something more valuable understanding of what true engineering excellence actually meant. When Richter died in 1998 at the age of 81, his obituary in the Stuttgart newspaper mentioned his distinguished career, his contributions to German engineering, his work on NATO projects during the Cold War. It did not mention the Browning M 1919 or the winter of 1944, when a captured American weapon had taught him the most important lesson of his life. But in his papers, archived at the University of Stuttgart, researchers found his wartime notebooks, his prisoner of war analysis, his dissertation on reliability in military systems. They found, preserved carefully for over 50 years, photographs of a Browning machine gun, its water jacket gleaming, mounted on a tripod in a Belgian forest. And they found a note in his handwriting, written late in life, summarizing what the weapon had meant to him. I learned more about engineering from studying this captured American machine gun than from 4 years of university training. It taught me that the best design is not the most sophisticated, but the most reliable. That lesson shaped everything I did afterward. I owe a debt to John Browning, an American I never met, whose genius was not in creating complexity, but in achieving perfect simplicity. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.